circle C with radius r lies only in the first quadrant. So that means if I've got my axes here, it's where x is positive, y is positive, just this top right part. So if I draw this part out slightly bigger, okay, I can draw my circle. Now we're also told that it touches the x-axis and touches the y-axis. There it is touching the y-axis. Okay, I'm just going to move it down. It's going to look something like this. Okay, obviously it could be bigger or smaller, but that is going to be what it looks like. And then we're told a line has equation 2x plus y equals 12. So y is equal to 12 minus 2x. Okay, so maybe that's going to be, say, up here. And it might come down like this. We're told to find the points of intersection in terms of r. Because this is going to, as the radius changes and the circle becomes bigger or smaller, then the points of intersection are going to change. So first up, the equation of the circle. Now the center, well, because the radius is r, this length is r, that means this, and also this length is r, that means the center is going to be r, which means the equation is x minus r squared plus y minus r squared equals r squared. Quite a unique circle here, but that's what it will be. Now, if we want to find the points of intersection, we can sub in, because in the final answer there's an x and an r, we can sub in for y. So I've rearranged it. So let me just write them both down. Y equals 12 minus 2x and x minus r squared plus. Okay, sub y into second equation. So then we will get x minus r squared plus 12 minus 2x minus r squared equals r squared. First bracket's not too bad. It's just going to become x squared minus 2rx plus r squared. I've avoided writing it as a double bracket, but you can. Second one, I think I would. I think we've got to be careful here because it's three things multiplied. So then this is going to be 144, 12 times 12. And then 12 times minus 2x, but you might spot there's going to be one here as well. So you can do it all together. Otherwise, you're going to get 9 terms, which is okay, but I'm going to try and speed up a little bit. So recognizing there's 2 terms here. Then I can do 12 times minus r and minus r times 12 there. So I'm going to get minus 24r. That's another 2 terms. Then minus 2x times 12 I've dealt with. I'm going to get a minus 2x times minus 2x. That's 4x squared. And then a minus 2x times minus r. And then one later on. Oh, not that one though. So that will actually give me plus 4rx. And then the only term I've not dealt with is this one here, plus r squared. Let's just count them up, make sure we haven't missed any. So I've got one term here, we've got 2 from here, so 3, 4, 5, 6, 7. Oh, sorry, that was just 6 actually, because it was 2x times 2x. So 7, 8, and then 9. Okay, that is going to be our expansion. So therefore, let's just write it out. X squared minus 2rx plus r squared plus 144 minus 48x minus 24r plus 4x squared plus 4rx plus r squared is equal to r squared. Okay, ready to cancel this down. We can cancel them out, leaving us 0 here. The x squared and the 4x squared give us 5x squared. Just going to put the think what we're trying to get up here. Okay, let's put the x terms together. So I've got 4rx minus 2rx, so that's going to be plus 2rx, then a minus 48x. Okay, I'll factorize that out in a minute. And then I'm left with r squared minus 24r plus 144 equals 0. Last step. Just factorize the x out, but put it to the right. And then we'll put this in a bracket because they have. Okay, and we're, sorry, apart from my pen malfunctioning, we are there. So that is an equation describing x, the points of intersection with the line and the circle, but it's in terms of r because the radius is, we're able to vary it. But we're then told that L is actually a tangent to C. So after everything, it's actually just going to glance off of it. And what happens here is that the quadratic only has one solution, i.e. the discriminant is going to be 0. So this is part B. B squared minus 4AC equals 0 if L is a tangent. Okay, this here is B, and this here is C, oh, and this is A. So 2r minus 48 squared minus 4 times 5 times r squared minus 24r plus 144 is equal to 0. There's different ways of cancelling this down. A nice way, like if you're trying to do this non-calculator, is that you could actually factorize out the 2 from inside here, and you could square them both. Okay, that is exactly the same thing, because if you bring it inside the bracket, then you just get rid of the squared. The reason I do that is that then I can just cancel these out. So then I've got r squared minus 48r plus 24 times 24. I feel like I should know that one. 576. I was thinking that, believe it or not, but I didn't want to get it wrong. And then minus 5r squared plus 5 times 24 is 120. And then 5 times 144 is minus 720. Then, oh, I think I missed an r out. R there. So minus 4r squared. And then 120 minus 48 is going to give me plus, it's going to be 72 r. And 576 minus 720 gives me minus 144. To be honest, you can just stick this in your calculator. I decided to divide through by 4. It becomes slightly nicer. So, and divide by minus 4 actually. So r squared minus 18r. And over here, we get 36. This is going to become plus 36 equals 0. I thought this might factorize. It doesn't. So you can put it in your calculator. That's what I would do. I mean, they even complete the square in the answers, but it should be fine to just state it at this point. To be fair, you could have done it earlier on as well. You didn't need to get rid of all the the common factors. This gives us 9 plus 3 root 5 or 9 minus 3 root 5. You can write it as plus or minus. I've decided to write them separately. Okay, so those are two different radii. They're okay. They're both positive. It's not like there's a problem with them. 2.2917. But it's asked us to leave it exact, but we should just check that they seem okay. 15.7. Two radii where that line L would be a tangent. Well done.